Hi, everybody. We're going to be doing P12, which is P11, which is convert an explicit formula to a recursive formula. In a lot of ways, this one's easier because we don't have to define our first term. We only have to define our common difference, which is the slope. So I'm going to try to explain it very quickly. If you have not done it yet, go back to P10 and take a look at it. That is by far and away the harder of the two sections. And the explanation to that one will help you understand this one. It's really hard to explain it going backwards because it doesn't relate exactly the way that you're normally think. So I want a recursive formula for this thing. And our initial formula, an equals 9n minus 38. A couple of things going on here. First of all, negative 38 isn't our first term. Our first term comes from putting a 1 in for the n, and that's going to be 9 minus 38, which is negative 29. So this is our first term. And to get to our next term, what's going to happen is instead of a 1 next for the n, I'm going to put a 2. So I'm 9 more than I was before. And it's not easy to see how this works, but it's going to add 9 each time because this number is increasing by 1. That n becomes 2. So I'm multiplying 2 9s, which means that I'm going to be at negative 20. And then I'm going to go up 9 again, and I'm going to be at 11. Negative 11, excuse me. And then I'm going to go up 9 again, and I'm going to be at negative 2, and so on. Now, the important part is that in order to get to any term, and if you know the term from before, all you have to do is add 9 to that. So this term is called A2. And if I know what A1 is, all I have to do is take A1 plus 9, and I get the next term, which is A2. For our formula, we're putting the n here, and we're doing the term that came before, which was n minus 1. So that's really what's happening. It's a n minus 1. It's the term before, and then I just add 9 to it. And I just keep doing that over and over again. I don't have to worry about this number because it's automatically taken care of by that the negative 29 is the first term, and I already know it. So here it is. I'm going to do a n minus 1, and then we're just going to add 9 plus 9. It's that easy. Now, I could have oversimplified this and just said you just add that number, but you really need to know where it's coming from. If you still don't quite get what I'm talking about, you may want to go back and look at P10. All right, guys, I hope that makes sense. In this one, it's a little hard to see, but what's going to happen is that there's really a 1 in front of that n. So an is really equal to 1 times n plus 35. And it's a good idea to go ahead and do a few of them. So if I put a 1 in for n, my first term is really 36. We sometimes call this the 0 term, the y-intercept. If you put a 0 in for n, you get 35, don't you? See what I mean? The next term is going to be one more than that, which is 37 and 38 and 39. And hopefully this makes sense. If you put a 1 in for n, it's going to be 1 plus 35. This is 2 plus 35. This is 3 plus 35, and so on. I was pointing at these. So clearly, in order to get from 1 to the next, I just have to add 1. And so I'm going to put in a n minus 1. Don't forget to move it back up to the top level, and it's going to be adding 1 every time. Let me erase this so you can see it a little better. There you go. Hopefully it makes sense to you. Let's take a look at another one. Oh, this is our easy one. Now this is kind of weird because it says that an equals 12. So it's 12 and 12 and 12 and 12, and then nothing's changing. So if you want to define each term in terms of the term that came before, this is my an. The term that came before is a to the n minus 1. And of course, they're equal to one another. So this is a n minus 1. And this is called a constant function. Again, we're talking about a n minus 1. A lot of people say, but what about the negative 73? Well, the negative 73 is already there. See, there's my first term. And to get to the next term, I just have to look at the one that came before. And to get to my next term, I have to look at the one that came before, and yada, yada, yada. Again, this is called a constant, in case you can't understand my accent. It's called a constant function. And we used to know it as y equals negative 73, for example. No matter what x you choose, you get negative 73. For a sequence, no matter which term you're talking about, it's always negative 73. Okay. Be careful. It's not the plus 47. That's going to be the part that you're going to get confused about. Remember, the 47 is our 0 term. And in order to get to the next term, it's going to be 9 times 1 plus that, which is 56. And it's 9 more. Remember, our slope or our rate of change for our y's is 9 every time the x's go up 1. This was our 0 term, or a0, if you like. We usually don't write this one. We usually start with a1, and then we go to the next term, which is a2. So that's going to be for 65, and then we're going to go up 9 more, and we're going to be at 74, and so on. Our common difference is plus 9. So if I want to get to the next term, I just have to add 9 to the previous term. A n minus 1. Don't worry, I won't over-explain every time. Plus 9. I know you just want to know, how do you do it? I want to get this over with. Don't worry, it's not so bad. Now, make sure you stick with me until I get to a geometric, okay, guys? Same deal. 9 is still there. We're just adding 9 every time. See, I told you I wasn't going to go crazy. Minus 1. Don't forget to move it back up to the, you see I was in the subscripts there? You need to make sure you move it up to the top so that when you put your plus 9, it's adding it to the whole term instead of just the subscript. Okay, this is a constant function, that's right. And remember, don't write that number. We're going to define it in terms of the term that came before, which was this one. That's what n minus 1, the a, n minus 1 stands for. The term that came before this one. Over-explaining. All right, a n minus 1. Okay. I know you want to get through it. N minus 1. There we go. All right. Next one. Geometric. Okay, so here's our geometric. Now there's a couple of things. This one's a kind of a tough one too. Wow. All right, let's do it. If n is 1, what's our first term? Well, when n is 1, this becomes a 0 exponent, and I have 50 times negative 4 to the 0 power. This is my first term in my sequence, which is 50. Because remember, anything to the 0 power is 1. And be careful. If you stick this in your calculator, you're going to say, oh, you made a mistake. I didn't. The difference is this is 1. This says take the exponent first and then tack a negative on it. Be careful. They're different things. And that's important. It'll be important when I write my function. Now, when I write my function, to get to the next one, what do I have to do? Well, what's going to happen is I'm going to multiply this number by negative 4. And the reason is because this is no longer going to be 0. When I go to the second term, it's now going to be 1. So I'm going to have an extra negative 4 that's getting multiplied. That's going to be negative 200. Then I'm going to multiply. This is the numbers that's going up. So I'm going to multiply by negative 4 again, which is going to give you 800. Not really important, but notice that the negatives are alternating back and forth. Now, the multiplier is the negative 4. So if I want to know how to get to this term, if I know this one, what do I have to do? I just take it and multiply it by -4, don't I? That's how I got there. So take your former term and multiply it by -4. I'm going to write it in this order. This is normally how you'd see it. So each time you want to multiply your former term by -4 to get to the new one. Obviously, it's much harder to read it from here going the other direction. Okay, what's my slope? Don't let this freak you out. Remember, -23 is my 0 term, and the next term is going to be -22. Notice it's only increasing by 1, and it's increasing by 1 because there really is a 1 in front of that n. So don't let it freak you out. It's okay. We're just adding 1, aren't we? Don't forget to go up +1. That's all. This is a constant function, something you can memorize. Make it easy. We like constant functions. Constant function. An exponential. Okay, so in order to get to the next term, we have to multiply by -5. I know you see that, everything's good. I probably don't need to go through it all again. I'm taking -5 and I'm multiplying it by the term that came before, which is a to the n minus 1. That's it. That's all you had to do. Every time you just multiply by -5. If you wanted to see the sequence and see that it works, it would be -10 because when I put the 1 in, it makes it -5 to the 0. I'll write it right here, -10 times -5 to the 0 power. And that's going to be 1, and that's going to give me -10. Then my next term is going to be -10 times -5 to the first power, which is going to be 50, isn't it? That's just 50. And then I'm going to get -10 times -5 to the second power, which is 250, but it's negative, because notice that that is a positive times a negative. Hopefully that's clear. Okay, what's our change? Our change is the rate of change is -8. So we're taking the 39, and then we get 31, and then we get 24, and it's going down 8 every time, isn't it? Going down, is that going down 8? No, 23. No, 23, yeah, 23, sorry. Can't subtract today. Goes down 8 to 15, goes down 8 to 7, and so on. Hopefully I didn't make any dumb errors there. But there's your sequence. But of course, our change is -8. So a n minus 1 -8. Not so scary. -5. A n minus 1 -5. Don't forget to go up. Getting there. 3 more, 3 or 4, maybe 4 more. All right, our common multiplier is -3, so we just put in our -3. -3 times a to the n minus 1. That's all. It is a constant function, a to the n minus 1. I shouldn't say to the, I should say a n minus 1. It's a subscript, not an exponent. A constant function. Common difference is -4, but it's getting multiplied, not added or subtracted. So it's -4 times a to the n minus 1. Oh, a n minus 1. There we go. One last one. This is our last one. I hope you guys will do it. Remember, it is your slope that's changing, and that's what's changing from one to the next. So I'm going to say it right this time, n minus 1, and we're just going to add 10, aren't we, every time. Hope you guys will try it yourself. Get your 100, and I'll see you back again. Bye.